Okay, so what is different about those equations that we did not do yesterday? What's different about the equations that we got there on the right? It has a number with the variable, right? We got a 6 right there, okay? Now, here's the good news. Nothing changes about the process. The process is exactly the same. We take what we're dividing by, we set it equal to 0. We solve for the variable. Now, the only thing that's different here is it's going to take you 2 steps to solve for the variable, because you got to add the 2, then you need to divide by 6. Now, typically, we would reduce that fraction. This is the one time I don't want you to reduce that fraction. I want you to leave it as 2 over 6. And there's a reason for that. I'll tell you when we get to the end of the process. So that's still the number that goes on the shelf. We still need to make sure that our numbers are listed in order. So highest powered exponent first. The highest power I see is 3, so its coefficient of 6 goes first. So after 3 comes 2, its coefficient was 46. After 2 comes just the plain variable, so that's 38. After the plain variable comes a constant, that's negative 27. Okay. This time we don't want to reduce. Okay, any other time we would. Okay, so process remains the same. We still bring that 6 down. We multiply by the number on the shelf. 6 times 2 over 6 is 2. Use your calculator if you need. Okay, add 46 plus 2, 48. Multiply by the number on the shelf. 48 times 2 over 6 is 16. Add, we get 54. Multiply by 2 over 6, that's 18. Add, we get negative 9. Box the last number always. Now, that's particularly important today, and here's the reason why we've always boxed it. Do these numbers look a little bit bigger than they were looking yesterday? Most of our answers didn't have double-digit numbers there. Or if they did, they were just in like the teens, okay? Here's the extra step to the process. When you get there, you divide all of those numbers by the denominator. And that's why we didn't reduce that fraction. We divide all these numbers by 6. And we're going to reduce them. So 6 over 6 is 1. Our original problem was b cubed, so that's b squared. 48 divided by 6 is 8. So that's b. 50 divided by 6 is 9. That's our constant. And then we put our remainder over our divisor. You never, ever, ever divide the remainder. You divide everything else but the remainder. So do not divide the remainder. Okay, and then here we divide by the denominator. Now, there was a little confusion when I did this with another class. Make sure that you're dividing by the denominator. In all of our examples here, the leading coefficient ends up being 1. That's not always the case. Okay, it is not always the case that you end up with a leading coefficient of 1. So you're not dividing by whatever number you brought down. You're dividing by the denominator from the shelf. Okay. Another thing to notice, even though we had a fraction up here, all of our numbers, everything except for the number on the shelf, were whole numbers. So if you're doing this process and you start to get fractions, stop and go back and check and make sure that you have your numbers in the right order, or make sure you have the right signs, because something's wrong. You should not ever get a fraction when you're doing synthetic division except for the number on the shelf. Okay, let's do a couple more to talk about a couple more details here. So number 2, it's in order. It's in standard form. P to the 4th goes first. We've got p cubed, p squared, p, and the constant. So we're not missing anything. Let's take 9p minus 2, set it equal to 0. Add 2 to the other side. Divide by 9. Don't have to worry about not reducing here because 2 over 9 doesn't reduce anyway. List our coefficients: 9, 25, negative 78, 88, negative 16. Bring down the 9. 9 times 2 over 9 is 2. Add 27. 27 times 2 over 9 is 6. Add, we get negative 72. Negative 72 times 2 over 9 is negative 16. 88 plus negative 16 is positive 72. So that's going to give us positive 16. So when we add, we get a remainder of 0. So that means that that divided evenly. When there is no remainder, it divided evenly. So 2 over 9 is a factor. 9p minus 2 is a factor of this polynomial. Okay? Divide by the denominator. So divide all these by 9. We started with p to the 4th, so we've got p cubed. Normally, I don't write that 1. I'm just writing it since we were dividing. Just writing it for clarity purposes. 27 divided by 9 is 3. That one's p squared. Negative 72 divided by 9 is negative 8. That one's p. And 72 divided by 9 is positive 8. And that's our constant. Divided evenly, there's no remainder. That's the answer. Any questions about the details? Okay, let's do one more, and then I'll let y'all practice. Okay, number 3, 5th degree. We start with v to the 5th. V to the 4th, I don't see v cubed. I also don't see v squared. So we must put zeros in that place. 7v plus 6 is equal to 0. Subtract 6 from both sides. Divide by 7. V equals negative 6 over 7. So negative 6 over 7 goes on the shelf. 7, 6, 0, 0, negative 35, negative 31. Promise you, if you don't have those zeros, it's going to mess up your answer. Okay, bring down the 7. 7 times negative 6 over 7 is negative 6. 6 plus negative 6 is 0. 0 times anything is 0. 0 plus 0 is 0. 0 times negative 6 over 7 is 0. Add 0 to 0, you get nothing. Got a whole bunch of zeros here. 0 times negative 6 over 7, still 0. Finally, not a 0. Negative 35 plus 0 is negative 35. Negative 35 times negative 6 over 7 is positive 30. Negative 1 is the remainder. So we started with v to the 5th. So v to the 4th, v cubed, v squared, v constant. Don't forget to divide by 7. So we've got v to the 4th. We don't need those zeros. And you don't need to go through and divide 0 by 0 because it's 0, or you don't need to divide 0 by 7 because it's always going to be 0. So v to the 4th minus 5 minus 1 over 7v plus 6. Just remember, when your remainder is negative, we put that minus sign right there. If it's positive, then it's plus sign.